Right. This is not going to be a history of Lake Winnebago from 1840 at all. That's about where we'll stop, maybe a little bit before. But what it is going to be is, well, let's see here. Here we go. All right, here we go. Number one is, thought I'd introduce it to you, where is Lake Winnebago is, by the way, I don't know if you know it, but it's supposed to be the largest natural inland lake completely in one state, United States. So we have that distinction. And being as we're going to be talking about geology, that's actually what my my graduate work and everything was, is in geology. But we're going to take a look as, number one, this program is going to be is why is Lake Winnebago where it is? And so there's sort of some unique geology that goes with it. And from this slide, you can just see is there's Lake Winnebago there. We will be talking about the Niagara Escarpment, and just for comparison, there's the Kettle Moraine, and you can see how it stands out very dark, even in the satellite image, 500 miles in space. So that's it. And the shape is somewhat reminiscent of Lake Michigan because you know the origin is about the same for both of them. And that's about where it's going to stop. Now, in eastern Wisconsin, you can see the Niagara Escarpment, which we call ledge. It's the tree-covered ridge that's locally known as ledge. It's where the story of Lake Winnebago began long ago, and I mean long ago. And so when we talk about it, that's it right there, that tree-lined ridge right there, that basically surrounds the city of Fond du Lac from the east and wrapping around to the south. Now, is the escarpment is a prominent landform which forms the east shore, east side of Lake Winnebago. And by the way, I also like storm chasing. I'm one of those people that, no, we're not nuts, but we know what we're doing. It helps. But anyway, is so, and I, as a geologist, one of my, I like structure, which is the bigness of things. And I like that in the weather too. So I like photographing the storms and that because these structures are rather interesting. But anyway, there you can see a giant thunderstorm, mesocyclone complex. But there again is, here's Lake Winnebago and of course the escarpment. And that'll come back. So if you get southeast of town and the high points, you can actually overlook the valley where Fond du Lac is. And this is wrapping around to the south, sort of towards Oakfield. So if you view from the escarpment to the south overlooking the city of Fond du Lac, you can see Lake Winnebago, which of course is going to be down in here. There it is right there. And of course, and there's the escarpment again, which again extends the entire length of Lake Winnebago from the north and then comes around and wraps south of the city of Fond du Lac. So on the map here, on the geology map, is the escarpment outcrops in a number of places. Mostly it's buried, but you can see where all these numbers are here. Is these are all places where the escarpment outcrops, so that it's you know, very prominent. You can go walk on it, do whatever you want. But right here is the area that we'll be interested in too, is the east side of the lake right up there. So that is the Niagara Escarpment. So I thought I'd start is, who really knows what the Niagara Escarpment is, where the name comes from, or any of that? Well, I'm going to tell you all that. But before we do, is just give you a basic geology map here. Here's where the lake is, and they show the muck down there. It's about 200 feet of muck at the bottom, and I'll explain this later. But here would be the Maquoketa Shale, which is actually what the lake is carved out of. And above that's the Niagara Dolomite. And so that's what's really important. Then what we have here is all the glacial sediments. So the Maquoketa Shale, Niagara Dolomite, and the glacier played a great part in the formation of it. And you can also see, as they used to call it, the Valor's Terminal Moraine. Well, that was the last great ice advance that came into the valley, helped form the lake. There were many, by the way. And so first we'll examine what Niagara Dolomites and escarpment are in the geologic and historic context. So, Niagara is an Iroquois word which translates as the neck or the bisected bottom land. And it was used to describe the portage where the Niagara River flowed into Lake Ontario. And so this is actually looking back towards Niagara Falls, but this is the Niagara River. And so when you get down towards Lake Ontario, that was the neck, and that was not as rough, and there was a portage there. And that's where the name came from. It was the bisected bottom land. It was a neck. Originally, when it first recorded, the name did not apply to the world famous river or falls. It was only that portage that the name applied to. But we took it and used it for the whole thing. The Niagara Dolomites would make up the escarpment of Silurian age. That's approximately 430 million years old. And the outcrop is a ring around the Michigan Basin, now a highland. So if you take a look at, this used to be a lowland, and right here, we're going to go back. This used to be a lowland here, and so that was brackish water for millions of years in which all the salt. Where does all the salt come from they put on the highways? You know where all the salt comes from? It comes from areas right down in here and over in here. Those mines are thousands of feet deep that they mine the salt out of that we spread on our roads here. How did 2,000 or 3,000 feet of salt get under Michigan? Good question, huh?
Historically.
But it's an old ocean, brackish ocean basin that dried up many times and replenished, dried up, until it built up all that salt through evaporation. So on this slide, as you can see, here's Fond du Lac would be right here, but the Niagara Escarpment actually wraps completely around it, and it's Niagara Falls is what it's named after. But this gives you an idea of what the Niagara Dolomites really are. Is we're basically the western end of Niagara Falls is what we are here. So how many of you knew all this stuff? Good. All right. If you look at it here, it's rather interesting because what we see here are actually the Mayville Dolomites. There's another formation. You go to the east, it's the Burnt Bluff, which is not quite as old as the Silurian, the Niagara. It's still Silurian age. But it's kind of interesting from my view is actually these are actually domes. You can see a dome structure in here. This was formed first. It was probably biologic in nature, but you can see the deposition after that up against it. And then what you see here is you see the glacial settlements. So the truth being, a child could put their hand across that interface right there, and you'd be spanning 430 million years of time. And everything from the Silurian to the Ice Age is just gone. It's gone. It doesn't exist. It's gone. Basically, weathered away. The question is at one point did girl dinosaurs and boy dinosaurs frolic in what is now Wisconsin? Possibly, but any evidence of it is long gone through erosion and not plate tectonics, but erosion because of what it is. So about 430 million years ago, during the Silurian period, what is now Wisconsin was actually located 20 to 22 degrees south of the equator and covered by shallow tropical seas. They're called the Pyrite Seas. There is, however, an earlier geologic period important in the future Lake Winnebago Formation. But what I did, I just showed you is here's the equator, and there's where what is now Wisconsin was, and actually it was rotated 90 degrees clockwise is what it was. How can you tell this? Paleomagnetics is one thing. The Lake Superior is actually a volcano that's totally collapsed. Lake Superior was a shield volcano, which is every bit as high as what Kilauea and that would be in Hawaii. That's about 1.1 to 1.1 billion years old. It all collapsed and thrown away at a time to form a depression. What's interesting is not one flow, it's many of them. That is where the first magnetic reversal of the Earth's magnetic field was recorded, is actually in Lake Superior. And through the paleomagnetics, whenever lava flows, as it cools, it locks in the inclination, declination of the Earth's magnetic field. So if they remove those cores and they take it to a lab, they can tell exactly where, north or south of the equator, that that feature was when it was formed. And what is now northern Wisconsin, not too far from us actually, was right down here, 430 million years ago. Now, if we go back about another 25 million years, what is now Wisconsin was in tropic, a little bit farther south yet at 25 degrees or so south of the equator. It was still covered by the shallow seas, and the sediments from the north were slowly washing in and accumulated in thickness. So basically to the north, which I've shown you here, is the north actually because it was rotated. The north would be in this direction. These are called the tectonic highlands. Those are the ancestral, those are the ancestral Appalachian Mountains. Those were formed by a collision between what is now Northern Europe and that area and what became the North American continent. And it's called an orogeny, but it's just like taking this. If I take two things and I shove it from both ways, it blows up, and that's how mountains are formed. So we know where the highland was, and we know basically about what time it was. Anytime you put something in the atmosphere, the rainwater, because it's acidic, and weathering, wind, to start breaking it right back down. Mountains don't live forever either. And so that was shedding a lot of sediment. That sediment was actually flowing south during this time towards the equator. And it's the thickest east, and then it shallows up as it gets here. But there's gives you an idea. So the sediments are coming off the highland and flowing in the shallow oceans in this direction, which built up the Maquoketa shales. So what I did was I just turned this 90 degrees on this side. There would be the equator. Kind of give you an idea, or here we are too. This is where we are now would be, is and north would be in this direction, of course, but that's where we were below about 25 degrees south of the equator, and we had a lot of sediments that were washing in at that time. And that would have been over millions of years as that mountain range basically weathered away. It's called the Maquoketa Shale. Maquoketa, by the way, who knows what the Algonquin Indian word for bear is? Makwa. Should all know that. There's going to be a test later on this one. But Makwa, and so Maquoketa actually indicated where the bears were on the river. Maquoketa, Iowa, is named, it's the only place name that has Maquoketa is in Iowa, but the Maquoketa River. And so that's where you get the name from. These sediments are known as the Maquoketa Shale. Shale is fissile. In other words, it's very platy. It's very platy, and it's different than clays. If you metamorphose shale, you get slate, for instance. And so just a little bit of what that material is. But they were being shed from the tectonic highlands to the north, and again, because of tectonic activity. So the thicker in the east, they were thicker in the east, which you would expect. So it's called a Queenston plastic wedge, but they're thicker this way, and then they taper out this way. So you'd actually have a wedge that kind of looked like the high point would be there, and then it shallows out, it gets in this direction. So they're very, very prominent in the east. There's good portions of the Adirondacks in that, for instance, in Maine, where you have what are called gray wackies, which is something that it metamorphosed into through tectonics. But that's where all the shale that's in Fond du Lac County, for instance, along the east shore of Lake Winnebago and grading into Iowa, that's where it all came from originally, was from the east. Now, for those of you who might know, but is the bricks that were all fired at the brickyards in Oakfield and at the brickyards up by High Cliff State Park, that's all Maquoketa Shale that they fired those bricks from. And so here is a shot from when the old kilns and that yet out at Oakfield when Gordy Kottke owned it. And here you can see there's the Maquoketa Shale, right there, that gray, and there are the Niagara Dolomites sitting right on top of it. So there you can really see a great interface. And because this was a shallow seas, there are a lot of fossils there. This is a world-class fossil bed. These are brachiopods and microsponges that can still be collected from the Maquoketa Shale pit at the old brickyard. And so I did that. There's one special one right here. These are actually microsponges. They're only about 1/4 of an inch in diameter. And I used to, I get a call from one or two of my old professors up at UW Oshkosh, and they asked me if I can go out and find in that whole brickyard some more of those little things this big. Took a good eye, I'll tell you that. But from universities around the world, geology departments would get a hold of UW Oshkosh and ask, can we get some of those microsponges from the shale pits and yeah, so I used to get them. So this is actually how we do know that. How do you get seashells in a place? Well, it must have been covered with the sea, right? Mm-hmm. And so that's how they got there. So there's just different kinds. There's about 3 or 4 different kinds or types, but these are just as you can see a little bit better in that one, for instance. Though brachiopods are a little bit different than clams in that because it's a difference between feeders and that. This is called sporifera, for instance, and there's just a number of in here. But you can tell, by the way, is whether the water was getting shallower or deeper by what you find in these quarries too. And so after all this shale was put in there, there came a shallowing up period during the Silurian, which in other words is the ocean became less deep. And so I'm just going to go into Silurian is known as the age of corals, the time when carbonate rock was formed by both organic and inorganic processes in the shallow seas. You can see this process going on in places that are called Sabkha, which would be like around the Arabian Peninsula in that area. You can actually see this process going on where Kim brought a point and I looked at it and I knew that it came off one of these old reefs, the material. If you see oolites in it, which they look like little oil spots, that's an indication of very shallow water because the process still continues. But we pretty good idea based on the modern counterparts is what was going on and where the materials were being formed at the time. And so this is just the geology time column is kind of interesting, but is here we have, for instance, this is the age of the dinosaurs right here is Mesozoic. That's modern history compared to where we're at. We're way down here in the Silurian. So we're about 250 million years older than the oldest dinosaurs. Okay, and that gives you an idea how early this really is. Now, because of plate tectonics, if you push two masses of land together, it's going to get like this. You're going to go sort of like hills and valleys. If you look at Pennsylvania, the fold belts. If you ever drove through Pennsylvania and I-80, this is the same process as when you have continental collisions. But is what you have is you had basins and highlands, There was the Wisconsin Arch, but then you had another arch, but then you have a basin over here and a basin over here. So you have basin, arch. So Wisconsin started to dome up at this time point, while Michigan became a basin, which is, of course, this basin right here, where around it, this was the deeper part here, and around it was the shallower part where the reef grew. And this is the same thing as happens in the islands in South Pacific and in other places. So a series of coral reefs developed on the edges surrounded by the isolated bowl-shaped Michigan Basin. Niagara Escarpment is one. It's an ancient fringing reef that surrounded the Michigan Basin. It's almost like the barrier reef in Australia. That's the correlation that you can make is about the same thing. And again, where were we? At this time, we were still well over 20 some degrees south of the equator when this was all happening. So warm tropical seas like that, it would have a lot of growth. And then the Niagara Dolomite Sea has got the same geological formation over which Niagara Falls flows and then plunge into the Maquoketa Shale. So if you've ever been to Niagara Falls, here's the plunge pool underneath all that. That's the same thing, Maquoketa Shale, that they make the brick out of here. It's the same stuff. That plunge pool is like a couple 100 feet thick. But it gives you an idea if we're just going to go back to that one. So that if you take a look at Niagara Falls, this is actually a quarry by Oakfield. It's the same thing. This might be a little bit younger in age, but you can see it's the same formation. And so where it plunges into the plunge pool right there, we get over here, that's the Maquoketa Shale, the exact same geology, except it's in upstate New York. So Niagara Falls, Niagara Escarpment, and Calumet and Fond du Lac counties. I think if you take a look at this picture, it's pretty evident. I had, who remembers Dick Kennard? Dick Kennard taught math. I had Dick Kennard like I had him for like couple of semesters, the calculus, everything else. Dick Kennard always used to say, it's a well-known fact to those who know it well. But it's a well-known fact to those who know it well that these are the same formation, Niagara Falls, that we have here. But if you take a look here, as you can see, there's Niagara Falls, there's Niagara Escarpment, Maquoketa is there. It's the same geology, the exact same thing. So if we could run a river over the ledge near Oakfield where the vertical reef is over 100 feet, we would have this. We'd have Niagara Falls. If we could run a river over the Niagara Escarpment by Oakfield, we'd have Niagara Falls. Same thing, except that it'd be in the east. All right, so ancient life forms collected from the escarpment tell us that it too was once part of the warm tropical sea, and the reef was teeming with marine life. This is where we get a lot of the really good corals, and so we have the halocites and favocites corals, for instance, and the halocites are the ones on the left, the favocites are the one on the right. They sort of look like a honeycomb, but these are actually true corals, the kind that grow in tropical seas. That's what the reef was built out of. Now, not all of it. Some of it's just sedimentation that's formed by evaporation, other things, but you had in that, you have what were called bioherms. The bioherms are actually high points. That was the reef. It was very, very rich and teeming with life. And so that's where you would have these kind of formations is the coral beds and what lives in those coral beds. So you would get gastropods or snails, horn corals. This is all stuff collected right in this area. So I used to be out there doing that more often, but a lot of it. As a matter of fact, there's one of the bioherms, if you know where the East Shore Conservation Club is and they have their shooting range there, the whole back berm is, you can go there and it's just fossil rich, the whole thing. So between the lead and the fossils, you know, but anyway, we have the sponges that are turned to stone. So that these came from Yam County, but that's a sponge. And then we have the remains of what are even hard-shelled squids. And these are typically small is when you find them. So what you can see with this one right here, this is actually like a squid, but it wasn't soft body, it was hard body. And so what you have is the septa, which are the segments from which these things grow. And so like a growth ring, and you can actually see that in these, but you can see that this is only a few inches across. So then as we also had the Spiriferida and the Rhinocolondia brachiopods, and they're very diagnostic when you find them. I would go out to Oakfield, for instance, right where all the glacial polish was, and there'd be some gravel laying in some of the depressions, and I can find the brachiopods right in there. And so that just not too tough to find them. And then we have, this is the Wisconsin State fossil, which is Flexicalamean trilobites, and we have the Penamarid brachiopods. So these things are actually a rather complex life form, the trilobites. And then, of course, we have, this is a very diagnostic brachiopod fossil that you can tell the age of some of the separations by these things. So we're not going to get, plus there's many others. Now, one of the coral reefs and life forms that are recognized in the fossil record and modern reef counterparts. You see, so this is at the Milwaukee Museum, where they actually created that. And I just showed you a lot of the fossils. So I mean, here you can see the corals here. You can see some of the corals. They have trilobites down in there, and here they have the squid. And you can see from the remains, we know what the squid looked like, because actually some of the soft parts have been preserved in those. So they're rather interesting as they were extreme predators cruising the reef, and the straight hard-shell cephalopods were ancestors of the modern-day squid. And like them, they could grow into giants some 40 feet long and more. This was an apex predator. The remains of one of these giants was actually found in a quarry near Mayville in Dodge County. And this is a segment of it. And when a seams fell, again, it was called regression. The reef and the rock, then they'd be subject to erosion in the atmosphere. And so that creates the distinct boundaries. And so, for instance, you can see right here, that's an erosion level. Then the seas rose again, it deposited this. Then the seas regressed again. You get erosion. You can actually see that there's about 7 levels in there. So this is over a very long period of time. But that's exactly what was going on here. And so we were above sea level. After that, we came above sea level when you get up into these areas. And so that's what thickened the escarpment into what it is. So, all right. So over those millions and millions of years, the dates were established by paleomagnetic studies. Plate tectonics eventually moved what became the North American continent from the south to the northern hemisphere, and it rotated at 90 degrees. So what was pointing east actually rotated so it became north, and we've been that way. So we're still moving. The whole continent, all the plates are still moving north. Where we are right now, you don't know it, but we're moving to the southwest at about the same rate that your fingernails grow every year. So we're moving about 2 degrees to the southwest, the entire continent. Which indicates, by the way, when Columbus came about 500 years ago, that's 1,000 inches, or about 1,000 inches at that rate. And so basically we had just divide the 8 into 1,000. The ocean is actually or 12 into 1,000. The there's actually about 80 or 90 more feet that the Atlantic Ocean has widened since Columbus got here because of plate tectonics. So, anyway, after land slowly rose and the seas evaporated, the diagonal is subject to the weathering in the atmosphere for hundreds of millions of years. Natural fractures formed, the sea entered, rain entered into them, dissolving and widening the cracks, forming caves and dolines or sinkholes. This type of landscape is known as karst topography. You can see that in a lot of the quarries here. This would have been, for instance, right here would have been a cave or a sinkhole. You can actually see the collapse structure in it. So that was a normal process. Now, this is a basically soil depth map. Because we are just being eroded away for millions and millions and millions of years. You had ancient rivers and other things that flowed in there and dissolved the water. You can actually tell a lot, but here's an old river cut right here over by Elkhart Lake in that area that's over 300 feet deep. That's all filled in with glacial debris. And so if we get over where we are in Wisconsin, this is a river valley right here at the edge of the escarpment where the river had flowed in there. And you get down at the southern edge right where Fond du Lac is, but over by Tucker's, if you could go down to your wall settlement, you'd find about 200 feet or more down, there's a V-shaped river valley that's there. And so that's just old river cuts that are into the either the Dolomites or the shale. And so,
is that the old Tuckers and
the one on South Main. So there's actually, that's one place I know from well logs that I've seen is that there's actually a valley that's like just what's shown on this map there. If we could take all the glacial debris and sediment away, it wouldn't look like this, but it would look like these fantastic scenes you see come out of China and parts of North Vietnam. This is called karst topography. That's because this is all limestone and dolomite, which rainwater is acidic. And so the rainwater will dissolve this. And so this would be the kind, not quite on that scale, but when we were doing a project over by Ashford, I remember talking to a couple of the farmers. There would be reef spires that would be sticking up out of the fields, reef spires, yet it'd be a structure that would look, well, like this. The tip of it would still be in the field. I remember a cow got stuck between two of them. We had to push the cow out. But when they set the telephone, all the power poles after the war, when the REA came through, they'd hit bedrock 5 feet in one place, they'd go 20 feet over the other way, they push it down and they couldn't hit bottom. They were in one of those valleys. So that's just how dramatic that topography is. So then 2 million years ago or so, after the land had been weathered in the atmosphere hundreds of millions of years, came the Ice Age. And it was late in this time period, the Pleistocene epoch, that present-day Lake Winnebago was born. So it took all these hundreds of million years and that geology to form it. The last great geologic event in the Great Lakes in Wisconsin history began approximately 2 million years ago with the Pleistocene epoch, commonly known as the Ice Age. This was the final event in a long, complex geologic history that provided Wisconsin with many gifts from the glacier, including Lake Winnebago. So, and this was the extent of those the glacial ice at that time period, which Wisconsin is really world famous in many ways for. But anyway, this shows you the glaciation in the United States, and this is about 2 million years worth of glaciation. But even you get down as far as Kansas, Nebraska, there's lobes of ice. But we stayed ice covered for about the longest. This area right here stayed ice covered for longer than any place in what is now the United States. And so we have very old rocks. We have rocks in northern Wisconsin that are 3.5 billion years old. We also have the youngest, some of the youngest landscape features there are, which is the whole Kettle Moraine area. It's only about 15 to 17,000 years old at the oldest, which is very young. And so this gives you an idea of the extent of the glaciation. And by the way, the glaciers at this time, when it came over first time and went all the way down to Illinois, that ice would have been about a mile thick. So these things were substantial. And it depressed the Earth's crust because of the weight so much that you go into a thing that's called isostatic rebound. Now, when I was in geophysics, we used to have to do these problems in rebound and try to determine how much the land had come up or whatever. But basically with the rebound, in about 3,000 years, it's like sitting on a cushion. When you get up, the cushion comes up. The Earth's crust is still doing that from all this ice. In about 3,000 years, the Great Lakes will drain south through Chicago. Because the tilt that'll come up in the north will tilt the whole Great Lakes south. They're tilted north now. And so this is really complex stuff. But when all that ice came through, it overrode the escarpment. It came right over the escarpment. The escarpment actually split one lobe. And so that you had the Green Bay, you had the Lake Michigan lobe and the Green Bay lobe. And so right in here was the split. But it still went through that Maquoketa shell. I mean, the shell is very soft. So I mean, it just tore that stuff to pieces. Now this just is something I wanted to show you, but advanced retreats of the Ice Age. So these are all advanced retreats. There's probably 16 major ones and a bunch of minor ones. The ice just came and went, advance and retreat, advance and retreat, advance and retreat. So is the climate warm and it go cold, warm and get cold. And so every time that happened, the ice would either advance or retreat. And so it came into what's now the Fox River Valley many, many times. And so note the impounded. When it did that, by the way, as it came from the north, it was always there, the glacier, is there that the north flow of what is now Lake Winnebago through the Fox River was blocked. And so that's when it cut the channel through to the Fox River into the Mississippi. This is when it happened. And about 4,000 years ago, a little bit somewhere right in there, the lake levels finally stabilized. And that's when we started to drain north through what is now the Fox River. All right, so by 25,500 years ago, the ice had re-advanced. And so here's the difference is just these advances and retreats. Here's 30,000 years ago. Here's 25,500. We know this is because there's beach ridges that are full of datable material. And so they would go to these beach ridges and test them. You could tell where the lake level was, get the carbon dates off of it. So that's how this was all recreated. So you can see that there's 30,000 years ago, 25,000 years ago, the ice had re-advanced. And so here's the beginning of the last glacial maximum, which was with Glacial Lake, Wisconsin. So 20,000 years ago, we had one of the last maximum re-advances into the Fox River Valley. It covered almost everything. It covered what is now the city of Fond du Lac. And so what you had over this way was it displaced the water that was in there from before. If we go back here, you can actually see water on the edges there. It shoved it farther to the west and formed Glacial Lake, Wisconsin. Now, this is, if you take Highway 39, you're over towards Adams County, and that whole sand plain, that's that old lake, that's that lake bottom. Is what that is. And also, by the way, where our groundwater comes from. The water that we drink, the city of Fond du Lac has been underground for 10,000 years before we pumped it out. And it starts out there. Flows gently down towards lake. So anyway, as you can see in this map, the Green Bay lobe glacial ice spread out to the south. As the ice came down, once it got past the escarpment into the valley, it flowed to the south, it flowed to the west, and it flowed to the east. How do we know that? Well, I'll show you. This is new evidence of glaciation from between 26 and 17,000 years ago. You can find on the Niagara Escarpment, where the glacial polished the bedrock smooth and less striation in the direction the ice flowed. So here you can see this is at Oakfield, the glacial ice advanced direction to the southwest. So it came from the north as it got out of the Lake Winnebago Basin. It's like a pancake batter, it just spread out. And so as it went towards Oakfield, it was flowing to the southwest, it was flowing south here and flowing southeast as we go over to the east part of the city. So if you get over to Oakfield and you get on where you have all the glacial polish, you'll find all the striations from all the gravel and everything else that was at the bottom of the glacier. It's just like a giant piece of sandpaper. And not only painted smooth, but it left all these striations in the direction of ice flow. That little girl that's in that photograph works for the sheriff's department. Been there for about 15 years. Anyway, where it went over the Niagara Escarpment south of Fond du Lac in the quarries, you can see where it was flowing due south. And so here it is. So there's one of my famous compasses, but there it is. And so it's north-south. That's in the quarry south. So Oakfield, we've got the ice flow in the southwest, south of us directly, we have it flowing south. And then when you get over, we got over to towards Oakfield, it's flowed toward the southeast. And it's just like pancake batters that came out of the valley and overflowed. So that's how we track the direction of ice flow. And there it is flowing toward the southwest. So these are just things. Also, by the way, is advanced, it literally bulldozed that much softer Maquoketa shale, which is at the base of the escarpment. It just tore that stuff out and just plastered it right up against the escarpment. And so you get over like towards Pebbles and areas and some of those old quarries there. That's where you can see it. And so what you have is you have lenses of the Maquoketa shale, the gray stuff, and then you'll have it mixed with sand and everything else. That was just a glacier just plowing that stuff out and just shoving it against the side of the escarpment. Future Lake Winnebago is now ice covered. So 17,500 years ago, the future lake is now ice covered, caused the meltwater of the ice edge to drain south through the Fox River into the Wisconsin River. And so that's when that whole system was created. So it can't flow north, so it actually cut through this the Fox and over towards this would be basically Wolf River Neck coming in, but it's all displaced and then in the Fox, and it flowed over towards the Mississippi. So that's when that was created. Then came a glacial interstate or period of ice melt and retreat between the glacial benches, but things were to change. So then the ice had retreated way back about 15,750 years ago. We were completely ice-free in the state of Wisconsin. During this time, a proto-Lake Winnebago was formed, but likely smaller than today and draining north at the time. And so that channel to the north would have been opened up. But you can also see, by the way, as Lake Michigan was much smaller too. Well, then what happens is we get another advance. This may have been the last advance of ice to what is now the city of Fond du Lac. And the moraine on the south side of Fond du Lac on the map was the southern edge of the advance and marks where the Valder's red clay ends. It's actually called the Eureka moraine now, but it gives you an idea is with some of the land features that we can still see. For instance, this right here, this moraine. This is if you go over to Martin House on Martin Road, the little hill, that's our last glacial advance. If you drive up to Oshkosh on Highway 41, you get right to the county line, you go uphill. That's this thing. It's well, we're gonna go back. We'll go back to this one. That's right here. And so we get up the county line. So, and that's where all that wonderful and marvelous red clay comes from. And by the way, is when I got out of high school a lot of years ago, before the military decided they needed me, is I worked for a summer for my uncle Bud's landscape and grading.
Oh, yeah.
And I would get used to all that red clay if we had to work in it. It would stick to your shoes, and your each shoe weighed 50 pounds. And so that's that red clay, but that's where it comes from. It's now called the Eureka moraine. So anyway, and so about 13,900 years ago, an ice advance to the north of Lake Winnebago extended east of two creeks, bulldozed down an entire forest that was growing there from that interstate. So that would have been, that forest was right in here, and it got all bulldozed down. Go up there, Kim, and show them, we actually have 14,000-year-old trees. Black spruce, want to go hold it up? He's the one that got it. So, got a lot of the wood and timber from that. This is one of them.
Again, is it black ash?
That's spruce, black spruce. So there it is. That's a 150-year-old tree that got bulldozed over by the glacier when it re-advanced into the valley. And so that log is 14,000 years old. So
Was 40 feet down, they were digging.
yeah, so it was covered by somewhere around 40 feet of red clay.
Oh, wow.
And the red clay is still on there. The red clay is still on there. And so then I took, because we had one, the other section there, if you want to see, we had a piece that was cut off there, polished, so you can actually see the rings. And so those trees, that's a 150-year-old tree, but because of the cold, the growing conditions were not the most favorable, so they didn't grow giant. But that gives you an idea of some of the dynamics behind it. So here's the 14,000-year-old wood. And These trees are all 100, 150 years old. Like I said, they were literally bulldozed. First off, the glaciers of north, but they were melting. And so what happened was the meltwater flooded and drowned out the trees. They get going, well, then came the whole glacier and just bulldozed them down and covered up with about 40 feet of red clay, and that was the end of that. So these were discovered near Menasha, and that forest went all the way over to two rivers, and so they called it, or two creeks, they called it the Two Creeks Buried Forest. But the spruce trees were cold adapted and evident for the cold to be found in the tundra conditions marked by short growing seasons. So and those very thin growth rings. So that just gives you an idea of some of the dynamics that are behind that. Glacial Lake, Wisconsin, the birth of Lake Winnebago. So basically, here's the last ice advance. This is about 12,900 years ago. Now, I wrote a paper. I was actually invited on to Joe Rogan, but I think he's an a-hole, so I didn't go on there. But I have my standards. But anyway, I'm not going to be made a fool of. That's all there is to it. Anyway, it looks like this last advance, it's called the Younger Dryas, and we had just this tremendous ice advance. It just happened just like, it might have been an extraterrestrial event. Probably got smacked by a comet. So it didn't leave the glaciers up north. Well, it restarted. There's dynamic, it restarted the ice age again. And it persisted for about 1,000 other years, just total ice age conditions. People were here, Indians were living in Wisconsin when this happened. And so I wrote a whole paper about that, which of course they go viral on the internet, but there's a number of oral legend that preserved from that. They called it the first burning of the earth. And when you read it, it's really rather compelling because they got, even with the flood epic and everything else, they got the chronology totally correct. So, but this happened 12,000. So that's the last time that we really had a lot of ice that came into the valley. And so after the ice retreated, farther north blocking drainage, Glacial Lake, Wisconsin formed at the base of the Niagara Escarpment. So from where the escarpment is covered the entire with the city of Fond du Lac. And so you can see the extent right here of how big that glacial lake was. It was quite a bit bigger than the lake is now. So if you go over to Lakeside Park, you can actually see these are these are wave cut terraces, and that was the lake level right there, 60 feet higher than what the lake is now. And if you look out, you can look, if you take, you can look out, and what you can see is it's all the way across. There's a bench, there's a bench, there's a bench. So that was the old lake level at the end of the ice age after it retreated and all melted. And so you can see the wave cut terraces and you can see the bench. And you can see them as you get back, you'll see a series of them going up the North Shore. That tells us that the lake was 60 feet deep at that time. So if I shot this, but that's where the lake level would be. The only thing that would have been sticking out that we could have seen at that time would have been like the hotel or the water tower or something. Where we are right now is under 60 feet of water. So at the end of the ice age. And then this is the view overlooking the valley toward Fond du Lac. 3 separate wave cut terraces are visible in there. And but then on the bench, this is where all the sand and gravel comes from, because that was all part of the glacial deposit too, against the Niagara Escarpment by the meltwater. You can tell a lot from these. You can see there's a lot of wind and wave action here. You can even see where there's an old river cut coming right through towards us there. So these are just all things. We used to go in there and collect samples and separate them out and do all kinds of stuff and marvelous, marvelous things. Then the Eureka Moraine, that's this one. That's the one that's south of Fond du Lac, or the one that you drive over. That was that's the last advance into what is now Fond du Lac. So that's why we have red clay in some parts, but you get south of that, it's all basically lake sediments and organics and stuff, the rich black soils. But here's where because it was the glaciers here yet, we have the red clays. And what's in the name? Well, Winnebago is an Algonquin name or word for Siouan-speaking people, so it's like a Chinese name for the Russians. Yep. And it actually translates as stinking water or brackish water people. The French name for them was the Puans, and Pu, and or the stinkards. So that name wasn't given to them. That's what the other ones called them. The name for themselves is Ho Chunk, various translated as sacred voice, or people with a big voice, meaning the mother tongue. So an idea. The earliest map that we have of Lake Winnebago was a Jesuit map made by Fathers Alois and de Blanc. It's a very accurate map. They didn't name it, they just called it an area that the Mascoutins lived there. Mascoutins are Potawatomi, the Fire Nation, the keepers of the flame. And then the first time you find a name for the lake is 1688 or so, is the lake is named Lake Francis Xavier, after the very famous Jesuit priest that had gone to China, St. Francis Xavier. Alois and I named the lake for him. For the sake of accuracy, this is 1718 map, but take a look at how accurate that map maker got Lake Winnebago, even the Fond du Lac River. And he never saw it. He only took descriptions that they sent him. He was in Paris. It persisted on maps. This is 1719 French map again. It's going to be called Lake Francis Xavier, and then it's still used on English maps following the French Indian War. They just took French maps, anglicized them, but they still called it Lake St. Francis Xavier. That's still, here's another English map from 1763. They called it then Kichigami Lake, which just meant Big Lake in Algonquin. And Ite Uni, this is a first map, one of the first maps of the U.S. in 1785 French. They called it Lake Kichigaman on there, which meant Big Lake. But it was right following the Revolutionary War, they called it Lake Winnebago. But they also called Green Bay is Puant Bay, and they named the Fond du Lac River the Crocodile River. And that they probably saw a garfish in there and thought it was a crocodile. And then the Northwest Territory, Lake Winnebago, by that time, 1814, you always see it named Lake Winnebago. Even this is about an 1829 map of Lake Winnebago by Doty, and so it's firmly named Lake Winnebago, and so that's when it persisted. Now, it's a marvelous place if you do pictures. Here's some of my personal favorite photography. I told you, I love storms. That was a bad one. Got hailed on, rained on, everything. You can see a funnel cloud descending over back there. Rainbows, everything else is that was a mean one. Here's another one. This is a shelf cloud, a mesocomplex. So the lake's a wonderful place overlooking the lake to do the photography. Here's one of those storms. John, Tim, you got one of these shots too. Remember the shelf cloud on edge? Got that. I heard all the sirens and everything going off north of us this is what my UFO, this is actually really interesting, is to have that structure in the storm. You can see that. Here's a tornado that I shot from Lakeside Park that was over towards Green Lake. Not quite Green Lake, probably more closer to Ripon. There it is. You can actually see there's the funnel cloud and everything else. Here's a water spout over the lake. Here's a mesocomplex superstorm over the lake. Those are Mammatus clouds. That dropped the tornado over by Eden when I took it. Here you can just see the blackness on the east shore and how rough the lake is getting. The sunset. Here's summer solstice overlooking the lake. Just look at that. We're looking over towards Doty Island from High Cliff State Park. Here's the harvest moon, the lighthouse. There's the harvest moon rising. There's the first really good comet I got to photograph with Lake Neowise. And then there's so there's Comet Neowise, and then the last one we had was the Comet Atlas. You go out to the park, you just have a marvelous view. Here's some of my aurora photography. So this is just the place to go. So give you an idea why I like that's looking straight up. So I hope you enjoyed the program as much as I did putting it on. And so that's what I do when I'm not babysitting.